Today we are going to look at chapter 6, which is trigonometric functions. The content standard 6.3 graphs of sine, cosine and tangent functions. And the learning standard 6.3.1 draw and sketch graphs of trigonometric functions. Now let's take a look at different types of trigonometric functions. This is y equals to sine x. Now for y equals to sine x, it is a periodic function and the shape of graph, meaning the shape like this, repeating in each period. For the graph of y equal to sine x, one period is 360 degrees or 2 pi radians. And you also see the amplitude here, right? So amplitude is the distance between the center line. Here is the x-axis between the center line and the top or the bottom of the function. Now for the graph y equal to sine x, you see that when x equal to 90, we have the highest point here where the value of y is equals to 1, and therefore the amplitude for the graph y equal to sine x is 1, and maximum value 1 here. For this y equal to sine x, the maximum value is 1 and the minimum value is negative 1. Right? Minimum value happens when x equals to 270 degrees. Now this is y equals to cos x, right? The graph y equals to cos x. Now, y equal to cos x is a periodic function and the shape of graph repeating in each period. Now for y equals to cos x, one period is equals to 360 degrees or 2 pi radians. And for this graph, the amplitude is also equals to 1. As you can see here, this is 1 here, this one negative 1. And for this graph, the maximum value is 1. For the graph of y equals to cos x, the maximum value is 1 and the minimum value is negative 1. Right? For the graph y equals to cos x, we have to remember the maximum value occurs when x equals to 0 degree and also 360 degrees, right? And the minimum value occurs when x equals to 180 degrees. This is the graph y equals to tangent x. The graph y equals to tangent x is a periodic function and the shape of graph repeating in each period. But for y equals to tangent x, one period is equal to 180 degree or pi radians. And you notice that there are two vertical dash line here. Dash lines. This is called the asymptote. Asymptote is a line which a curve will approach close but will not touch. No matter how far you draw the curve, it will not touch the asymptote. You can try using your calculator. You substitute x equals to 90 and you press tangent 90 and you will not have any values. The same goes for 270 degrees. And therefore, the value of tangent x is undefined on asymptote. Right? And because of that, the curve of y equals to tangent x does not have the maximum or minimum values, because it can keep on going up or keep on going down. So no maximum or minimum values. Alright? Okay, now let's take a look at this type. Y equals to a sine bx plus c. With a, b, and c, there are constants. Alright? So, what is the effect of the changes in the constants here? A, b, and c. Now, when the value of a changes, it will cause a change in amplitude. You see here, amplitude equals to a. So amplitude depends on the value of a. When the value of a increases, the amplitude of graph increases. When the value of a decreases, the amplitude of graph decreases. Now, when the value of a becomes negative, take for example y equals to negative sine x, then the graph is reflected by x-axis. Let's look at the effect of changes in the value of b, right? B here. Now, the changes in the value of b will cause the period of the graph to change. When the value of b increases, the period of graph decreases, the opposite, and the width of the graph in each period decreases. And when the value of b decreases, the period of graph increases, and the width of graph in each period increase also. Okay. So for this one, the shape of graph repeated b times in 360 degrees or 2 pi radians. So b will determine the number of times this graph will be repeated. Okay, and the effect of changes in the value c, it will cause a change in the position of the graph. Right? So when the value of c increases by, let's say, 2 units, then the position of the graph, the whole graph, will be shifted up 2 units vertically. And when the value of c decreases by, let's say, 2 units also, then the position of graph will be shifted down 2 units vertically. So if you have positive value of C, then the whole graph will be shifted up vertically. And when you have negative value of C, then the whole graph will be shifted down vertically. Alright, so those are the effects of the changes in A, in B, or in C. And this is y equals to A cos bx plus C. Again, A, the changes in A will affect amplitude. You see here, amplitude here. And the changes in B will affect the number of times this graph of cos x be repeated. Okay, the shape of graph repeated b times. If we have b here, b times in 360 degrees or 2 pi radians. Again, if you have b equals to 2 as a cos 2x here, then you will see that this shape will be repeated 2 times. And for C, again the same. If C is positive, then the whole graph will be shifted up vertically. And if C is negative, it will be shifted down vertically. Alright, so that is for y equals to A cos bx plus C. Now this is y equals to A tangent bx plus C. Now for tangent graph, the A here, the changes in the value of A does not have significant impact on the graph because there is no maximum minimum for tangent graph. But B here does have impact, right? The shape of graph of this graph repeated b times in 360 degrees or 2 pi radians, meaning the whole graph here, the whole shape. Again, if you have 2x, then it will be repeated 2 times. And the changes in C are still the same. If you have, let's say, positive 3, then the whole graph will be shifted up by 3 units vertically. And if the C here is negative 3, then it will be shifted down, the whole graph will be shifted down 3 units vertically. Right? The same. Now let's look at this question. Draw the graph of y equal to 5 sine x plus 2. So now A here is 5, B 1, and C is 2. So remember, the A here will affect the amplitude of the graph, and the 2 at the back will cause the graph, the whole graph, being shifted up by 2 units. Then important point to note here also is the word draw. So when we are asked to draw, meaning you have to use a piece of graph paper, you need to have the x-axis and the y-axis, and you have to plot the points first before you can draw the graph, and therefore we need a table, right? You come up with a table and put in the values for x. So we have 0 degree, 45 degrees, 90 degrees, and so on, or has a difference of 45 degrees. And you substitute the values of x into the function, you will get the values for y. For example, if you substitute x equal to 0, then the value of y is 2. If you substitute x equal to 45 degree, then you have y equals to 5.54, and so on. Alright, then you have the whole table completed, and then you have a piece of graph paper. You draw the x-axis and the y-axis, and you plot all the points, and you can draw the graph like this. You notice that if we have y equal to sine x only, then when x equal to 0, y is also equal to 0 at this point here, down here. But now we have 2 at the back, meaning the whole curve been shifted up by 2 units, and therefore when x equal to 0, we have y equals to 2 been shifted up. And for y equal to sine x, the maximum value is 1. But now we have 5 here in front. Remember, the value of a will affect the amplitude of the graph. So initially it should be 1, but we have 5, a equals to 5, so initially if we only have y equals to 5 sine x, then the maximum value should be 5. Again, we have plus 2, so the whole curve or the whole graph is shifted up by 2 units. So 5 plus 2, we have 7 here. Right? So those are the effects we can see in this graph. And again, if we have a equals to 5, if we only have y equal to 5 sine x, then the minimum value should be negative 5. But we have plus 2 here, been shifted up by 2 units, and negative 5 becomes negative 3 down here, right? You see this one. The maximum and the minimum values are different now. So that is the graph of y equals to 5 sine x plus 2. And remember, please, if you have draw, then you need to have a table with the values for x and y calculated correctly, and then you plot all the points correctly on the piece of graph paper. Then only you draw the graph, right? Next, what if we are asked to sketch the graph? Sketching the graph, then we do not have to use a piece of graph paper. So sketch the graph of y equals to the modulus of 6 sine 2x. Now we have 2x here. This is b. B. So 2 means the graph of sine will have to repeat it twice, right? 2 times. So if we only have y equals to sine 2x, then we will have 2 times the shape of the sine graph. 1 and then 2 within the 2 pi radians. But we also have 6, which is the a here. And because of that, you can notice that the maximum value here is 6. And the minimum value, if we only have y equals to 6 sine 2x, then the minimum value should be negative 6. But now we have modulus. So modulus means all the negative part now becomes positive, right? So it is like being reflected on the x-axis also. It comes out like that. That is the graph of y equals to the modulus of 6 sine 2x. So during the exam, if you are asked to sketch, then you don't have to use graph paper. You can, but remember, you need to draw your graph beautifully. And then for the x-axis and the y-axis, please use a piece of ruler to draw. Alright, make it look nice. Now, let's look at another one. Okay, another one. So this one again is contains standard 6.3 graphs of sine, cosine, and tangent functions. Learning standard is 6.3.2. Solve trigonometric equations using graphical method. Alright, see how we can do that. Let's look at this example. A. Sketch the graph of y equals to -3 sine 3 per 2x for x between 0 and 2 pi. Now you notice here we have 3 per 2x, meaning the graph of sine, the shape of the graph of sine will be repeated 1.5 times. And A is -3. If it is only 3, then we have maximum value because it will affect the amplitude. We have maximum value 3, minimum value -3. But now you have negative in front. Remember, negative means the whole graph will be reflected by the x-axis. Alright, so we will have a look. And B, hence using the same axis, meaning the x and the y axis the same, sketch a suitable graph to find the number of solutions for the equation pi per x plus 3 sine 3 per 2x equal to 0 for x between 0 and 2 pi. So for part A, sketch the graph. So it is better that we can come up with a table like this, and then you choose the values for x. Alright, I write down the values for x. Here we have 0, pi per 3, 2 pi per 3, and so on. A difference of pi per 3, 1/3 pi. And then use the values of x here, substitute into the function, and you will get the values of y. And then you have 0, 0, and x equal to pi per 3, then your y equals to -3, and so on. When you have this table, then you are able to sketch the graph correctly. Alright? And for B, we are asked to draw a suitable graph. So how should we do that? Later we are going to look at the two graphs at the same time, because it's on the same axis. Now, if we are given pi per x plus 3 sine 3 per 2x equal to 0 like this, then you got to remember in A we have drawn y equals to -3 sine 3 per 2x. So we have to try to get this -3 sine 3 per 2x. For this question, it is quite simple. We just bring this 3 sine 3 per 2x to the right, then you have this already. You see here? These are -3 sine 3 per 2x. Then on the left we have pi per x. So this is the one that we have to draw, this graph. Right? So to sketch the graph of y equals to pi per x, again we need a table. Now if you look at the graph, y equals to pi per x, then this is per x. Right? then I think you have learned how to draw this kind of graph. Because it is positive, so it should be well, in the first quadrant of the in the first quadrant between 0 to 90, but now is x and y axis, right? First quadrant. So because it is per x, so when x is equal to 0, then y is infinity, meaning undefined also, but you will not touch the y-axis. But when x equal to pi, then you have 1, x equal to 2 pi, then you have 1 to 2. Alright, so now let's look at the graph. So first one, we have y equals to negative 3 sine 3 per 2x. So 3 per 2x, meaning we have 1.5 of the sine graph. So initially you have 1.5, starting from 0 until 4 per 3 pi, that will be 1 complete shape of sine graph, and a half. So we have half here, from 4 per 3 pi to 2 pi. Alright, then supposedly it is up here. Up here, the graph, the sine graph should be going up like this. Here should be going up like this. Correct now? Yeah. And then coming down. But because of the negative sign here, negative, therefore it is being reflected, then it comes down, right? And negative 3. So you have a 3 here, and it goes to negative 3. So it will affect the amplitude. We have the maximum value equals to 3, and the minimum value equals to negative 3. For y equals to negative 3 sine 3 per 2x, right? So this is the graph. And the other one is y equals to pi per x. And if you plot accordingly, you notice that it will not touch the y-axis. It cannot touch the y-axis. And then if you draw it, then you will notice that it will the two graphs will intersect at 2 points. One is here, another one is here. Right here. Okay, so the number of solutions, meaning how many points of intersection. So here, if we have 2 points of intersections, then the number of solution is equals to 2. Alright, the number of solution is equals to 2. Alright, let's look at another example. Sketch the graph of y equal to 2 minus the modulus of tangent x for x between 0 and 2 pi. So first of all, we look at tangent x. Alright, tangent x. So for tangent x, the graph will be here, going up. Alright, so down here, continue to the third quadrant up here, and another one is for the fourth quadrant, it is down here. Then we look at the modulus. So for modulus, it means the negative part now becomes positive. So for the first part, no change. For the second part, it will go up here. It will come up here and continue to the third quadrant, And lastly, the last quadrant, also the negative part now becomes the positive. Becomes positive. Alright? For the first quadrant, the same, huh? Up here. And then we have the negative. So negative means the whole graph will be reflected at the x-axis. So when it is reflected at the x-axis, meaning it will come down here. For the first quadrant, comes down here. Then the second quadrant, now we come back to this part. And the third quadrant also reflected at the x-axis, comes down here. And the last one also comes down here. Then we look at plus 2. There's a 2 in front, right? So plus 2 means the whole graph will be shifted up by 2 units. So when it is shifted up by 2 units, then you notice that the graph here, when x equal to 0, y equal to 0 initially, now becomes 2. Because it has been shifted up by 2 units. Right? The whole graph been shifted up by 2 units. And the same goes for all the rest. And finally, you have this graph in blue, solid line in blue. That is the graph for y equals to 2 minus tangent of the modulus of tangent x. Next, we look at this question. Sketch the graph of y equals to the modulus of 6 sine 2x for x between 0 and 2 pi. So, we start with sine 2x. Alright, so sine 2x means within the range of 2 pi, we have 2 circle of sine x, which is here. Right, you notice here. Down here, coming down, one whole circle of sine x, and then another one here. That one is for sine 2x, and we have 6 in front. So 6 will determine, this number will determine the maximum and the minimum values for the graph. So that's why you notice that the maximum value for this graph here is 6, and the minimum value is -6. Then we look at the modulus. So modulus means the negative part will become the positive value. So we have the graph here. These are positive, then no change. The second part, the negative part, become positive. So becomes a graph up here above the x-axis. And the third one here, no change, still the same. And lastly, the negative part becomes the positive here. So this is y equals to the modulus of 6 sine 2x. Alright, the graph that I have colored in red. Now let's look at this example. Sketch the graph of y equals to 2 cos 1 per 2x for x between 0 and 360 degrees. So for this graph, we look at cos 1 per 2x, which means between 0 and 360, we only got half of the graph of cosine. That is why if you look at this graph, you see that it only consists of half of the shape of the graph of cosine x, because we have cos 1 per 2x. And the number in front, which is 2 here, it determines the maximum and the minimum values of this graph. So we have the maximum value here, which is 2, and the minimum value negative 2. So this is the graph for y equals to 2 cos 1 per 2x between 0 and 360 degrees.
Let's try some questions from this topic by using the QR code or link shown on the screen. You can check your answers with your teachers.
Our lesson today is circular measures. In this chapter, you need to know how to convert degrees to radians and how to convert radians to degree. There are 5 important formulas. Let's look at it one by one. First, length of arc S equal to r theta. For this data, please measure the unit is in radian. Second, area of sector. A is given by 1/2 r squared theta, and this theta must be in radian. Third, area of the segment. That is the gray color region here. A, the area is given by 1/2 r squared bracket theta minus sine theta. This one the theta must be in radian units, and the sine theta here, it must be in degree. Fourth formula is the length of chord. It's given by 2r sine theta over 2, and for this one, the units must be in degree. The last formula for this chapter is the area of the triangle is equal to 1 over 2r squared sine theta, and this sine theta, the unit must be in degree. Let us look at the first example. The diagram shows two concentric sectors OPQ and ORS with common center O. Given that OQ equal to 7 cm and the length of the arc RS is twice the length of the arc PQ, find the length of QS. That is this blue line. The questions tell us here the arc of RS is twice the length of the arc PQ. Therefore, we can equal RS to 2PQ. Let us find the length of the arc PQ first by using this formula S equal to R theta. For the sector OPQ, the radius is 7 and the angle is 0.5. So we multiply 7 with 0.5, I get 3.5 cm. The length of the arc RS is 2 times of PQ. So 2 times 3.5 get 7 cm. Next, we have to find the length of the OS. That is the radius of ORS. By using the same formula S equal to R theta. 7 equal to 0.5 OS. So OS is equal to 14. Our aim is to find QS. QS is equal to OS subtract OQ. That is 14 subtract 7 is equal to 7. B. Find the area of the sector ORS. Area of the sector ORS is given by this formula 1 over 2r squared theta. So the radius of this sector ORS is given by 14 here. We just substitute the 14 into the formula and theta is still the same, 0.5. Then we get the answer 49. Example 2. The diagram shows a sector of a circle with center O and a radius of 4 cm. The length of the arc AB is 5 cm. Find A. The angle of AOB. There is this angle. Question say the length of the arc AB is 5 cm. So we have R theta equal to 5. The radius is equal to 4. We substitute in, we get 4 theta equal to 5. So for it, theta is equal to 5 over radius. Therefore, the angle of AOB is 1.25 radians. Part B. Find the area of the straightened segment. We can find the straightened segment by using the segment formula. That is 1 over 2r squared bracket theta minus sine theta. The radius for the sector AOB is 4. So we substitute in the value and the angle of AOB is 1.25 radians. So we substitute it into the theta here. However, for sine theta, we must remember this one must be in unit of degree. Therefore, we have to do the conversion first. 1.25 radians is equal to 1.25 multiplied with 180 degree over pi. Then get from calculator, the answer is 71.61 degree. We substitute in the values. Solve for it and you get the answer is 2.408. Example 3. The diagram shows a circle with center O and diameter 10 cm. That is radius equal to 5. Given that the length of the minor arc EF is 8 cm. Find the values of theta in radians. So, we use the formula S equal to R theta. We substitute S equal to 8 and R equal to 5 into the formula, and solve for theta, we get 1.6 radian. Part B. Find the length of the major arc EF. We still use the same formula, that is S equal to R theta. We substitute 5 into the radius. However, for the theta here, we need to calculate it. We all know that a full circle has 360 degrees, or equal to 2 pi. So, for the angle of the major arc EF is equal to 2 pi minus 1.6. We multiply 5 with 2 pi minus 1.6, we get 23.42. This is the length of the major arc of EF. And the angle of the major arc EF, that is 2 pi subtract 1.6. Multiply it, you get the answer of 58.54. Example 4. The diagram shows two concentric sectors OPS and OQR with common center O. Given that angle POS is equal to 0.8 radian, RS is equal to 3 cm, and the length of the arc PS is 4.8 cm. Find A. The length of the arc QR. To find the length of the arc QR, we need to know the radius, that is OQ, but it is not given in the questions, so we need to find it first. OQ is equal to OP plus PQ. Let us find the OP. Length of OP is given by S equal to R theta. We can substitute in the values of the angle POS, that is 0.8 radian, and the arc 4.8 into the S here. We solve for OP and we get 6. OP is 6. OS is also 6. Therefore, we found OQ is equal to 9. Length of QR is equal to R theta. We substitute the radius OQ, that is 9, into the formula and theta 0.8, and multiply them, we get the answer 7.2 cm. Next, we find the area of the shaded region. The area of the shaded region is given by the area of the sector OQR subtract the area of the sector OPS. The area of the sector OQR is given by this formula 1/2 R squared theta. We substitute in its radius, that is equal to 9, and the angle 0.8 radian. Then for the area of sector OPS, the smaller sector, the radius is 6. We substitute into the formula and the angle is 0.8. We subtract it and we get the final answer, that is 18 cm squared. Example 5. In this diagram, PU and RS are common tangent to the two circles with the center Q and T. The radii of the circles are 16 and 6 cm respectively. The length of the tangent RS, the red line here, is 24. Angle RQV in radian, so is this angle. Look at this trapezium. I extract this trapezium and divide it into two parts. That is, one right angle triangle and a rectangle. I name this point as M. ST is equal to 6, therefore Rm is 6 too. And from the diagram, we know that the radius of RQR is equal to 16, therefore MQ is 10. RS is 24, MT is 24 too. Now, we can solve the data by using trigonometry function. The opposite of this data is 24, that is the opposite. And this is the adjacent. So, O over A. The trigonometry function that we can use is the tangent. Tangent angle RQV is equal to 24 over 10. Then get from your calculator, shift tangent 24 over 10, you get 67.38 degrees. Convert it to radian is 1.176 rad. Part B. Find the length in centimeter of the minor guard WS. There is this purple line. We have to first find out what is the angle of this WTS. I want you to look at this trapezium. The sum of the interior angle of the trapezium is 360. Since here is 90, 90, so the sum of this angle RQV and the WTS equal to pi. Therefore, we can have this. Angle of WTS plus 1.176 radian is equal to pi. Then we shift the 1.176 radian to the right. We get angle of WTS is equal to 1.966 radian. We can find the length of this minor arc WS by using the formula S equal to R theta. The radius 6 multiplied with the 1.966 radian, we get the answer 11.796 centimeter. Part C. Find the area in centimeter square of the shaded region. How are we going to find this shaded region? We can actually solve it by first looking for the area of this trapezium. The parallel line of this trapezium is RQ 16 and ST 6, and the height of this trapezium is 24. Then we subtract the sector RQV from the trapezium and the small sector WTS from the trapezium. Now let us find the area of this trapezium. The area of QRST equal to 1 over 2. Sum of the parallel line, that is 16 plus 6. Then multiply with the height of the trapezium. Then we get 264 centimeters square. Next, we find the area of the sector RQV first by using the formula 1 over 2 R square theta. Substitute in the radius QR into the formula, that is 16, and multiply with the angle here, 1.176, and solve it. We get the answer 150.528 centimeters square. Then we look for the area of the smaller sector WTS. Using the same formula, sector formula, 1 over 2 R square theta. We substitute in the radius of the smaller sector here, that is 6, into the equations and multiply with the angle here. The angle here we have found in previous part, that is 1.966. Using your calculator, solve it, you get the answer is 35.388 centimeters square. Area of the shaded region is equal to the area of the trapezium. Subtract the area of the sector WQR and the sector of WTS. Get from your calculator, you will get the answer is 78.084 centimeters square. Example 6. The above diagram shows an arc AQB of a circle with center O and the radius 6 cm. AQB is a semicircle with center N and the radius of 5 cm. Find A, the angle of AOB. B, the area of the segment ANBP. C, the area of the shaded region. We solve for part A, the angle of AOB. We divide this triangle AOB into two right angle triangles. Then we look at this right angle triangle AON. The length AO is the hypotenuse of the triangle, that is 6 cm, and AN is the opposite of the triangle, that is 5 cm. Since we know the opposite and the hypotenuse of the triangle, we can use sine function to solve for the angle AON. Sine AON is equal to opposite, that is 5 over hypotenuse 6. Therefore, the angle of AON is equal to 0.98511 radian. The angle at AOB is 2 times the angle of AON, that is, we multiply 2 with the 0.98511 and we get 1.9702 radian. Part B. Find the area of the segment ANBP, that is this yellow region. How are we going to find this region? I use this diagram to help you to get a better understanding. We can find the area of this triangle AOB and subtract it from the area of the sector AOB to get the area of the segment. And actually, we can solve this part B by using the formula of area of segments is equal to 1 over 2 r squared bracket theta minus sine theta. Look at this sector. The radius of this sector is 6, so we will substitute in the 6 into the formula. And the theta we have found it in the previous part, that is 1.9702. We substitute in to the formula. And for this sine theta, we must be very careful. This sine theta here, the units must be in degree. Therefore, we need to do the conversion first. We need to convert the radian to degree by using this formula. We multiply 1.9702 with 180 degree over pi, and we get 112.87 degree. We substitute this into the theta here and get from your calculator, we get the answer is 18.88 centimeters squared. Let's solve for the part C, the area of the shaded region. That is this yellow region. The area of the shaded region is equal to the area of the semicircle AQB subtract the area of the segment ANBP. The area of a full circle is equal to pi r squared. Therefore, the area of a semicircle is 1 over 2 pi r squared. Radius for this semicircle is equal to 5, so we substitute it into the r here. Then we subtract 18.88. This one we have found it in our previous part. Then use your calculator, we get the answer 20.39 centimeters squared. Example 7. In the diagram, OPQ is the sector of a circle with the center O and radius 15 cm. Given that the ratio OR to RQ is 2 to 3, find A, the length of the OR, B, the length of the arc PQ, C, the area of the shaded region. Let's solve for part A to find the length of OR. From the questions we know, the ratio of OR to RQ is 2 to 3. We can write OR over OQ is equal to 2 over 2 plus 3. That is equal to 2 over 5. Then from the diagram here we know OQ is equal to OP. This is 15. So we substitute in here and cross multiply it. You will get the answer OR is equal to 6. Let's solve for part B to find the length of the arc PQ. To solve this, we can use the formula of length of arc, that is S equal to R theta. From this diagram, we know that the radius is equal to OP, that is 15. So we can substitute in the 15 here, and the angle in the diagram for the sector POQ is 30 degrees. For this part, we must be very careful because the data here must be in the units of radians. Therefore, we need to do conversion to convert degrees to radians. That is, we have to multiply 30 degrees with pi over 180. Then we get 0.5236. We use the calculator to solve it. The final answer we have is 7.854 cm. Part C. Find the area of the shaded region. The area of the shaded region is equal to area of the sector OPQ. Subtract the area of the triangle OPR. For this area of sector, we can use the formula of sector to find it. That is 1 over 2 R squared theta. We substitute in the radius OP, that is 15, and also the angle, that is in terms of radian, 0.5236 into the formula. Then subtract the area of triangle. The area of triangle is given by this formula 1 over 2 multiply with the base multiply with the height. So we let this be the height, RS be the height of the triangle. Then area of this triangle will be given by 1 over 2 multiply with OP multiply with RS. I will substitute 15 into the OP. Now we have to look for the height RS. OSR is the right angle triangle. Therefore, we can use the trigonometry function, that is sine function, to solve for RS. Sine 30 is equal to RS over OR. OR is not given in the questions. Therefore, we need to look for the values of OR first. But we know that the ratio of OR to RQ is equal to 2 to 3. Therefore, the OR can be found by 2 over 5 multiplied with 15. Then I get 6. So substitute into here. And then I cross multiply. I get my RS equal to 6 sine 30. That is equal to 3 cm. Substitute in the 3 into the formula. Then use your calculator. Solve for it. You get the answer is equal to 36.41 cm squared. Now let us look at the example 8. The diagram shows a wall bulan that has an axis of symmetry MN. PQR is an arc of the circle with center M and radius of 40. Center M here, radius 40. And PQR here is the arc of the sector. PSRB is a semicircle with center S and diameter of 64 cm. So the radius is equal to 32. ABC is an arc of the circle with the center N, here, and the radius of 24. The length of the arc of ABC is 37 36 cm. So find A, the angle of PMR in radian. That is this angle. We look at this triangle. I divide the triangle PMR into two right angle triangles. Then I let this angle be theta. Angle PMR will be equal to 2 theta. Now we look at this triangle. This is a right angle triangle. Therefore, we can solve for theta by using the trigonometry functions. 32 is the opposite of the triangle. 40 is the hypotenuse. We have opposite and hypotenuse. Therefore, we can use the sine function. Theta is equal to shift sine opposite, that is 32, over the hypotenuse, that is 40. Use your calculator and get the answer. The answer is 1.8546 radian. Part B is to find the area of the segment PSRQ, that is this yellow region. The area of the segment PSRQ is equal to the area of the sector PMR subtract the area of this triangle PMR. Actually, we can use the formula of the area of segments that we have learned before. That is 1 over 2r squared brackets theta subtract sine theta. The radius of this sector, that is PM, is given 40. We substitute it into the formula here. And the angle for the sector PMR, we have found it in our part A. That is 1.8546. We substitute it into the formula 2. As for this sine theta, don't forget that these units must be in degree. Therefore, we need to convert the radian to degree by multiplying it with 180 over pi. And we get 106.25 degrees. We substitute in the value here. Then solve by using the calculator. You get the final answer is equal to 7,153.68 cm squared. Part C is to find the area of the shaded region. Let's look at this shaded region first. This shaded region is given by the area of the semicircle PSRB. Subtract the area of the segment PSRQ. We know that the area of a circle is pi r squared. Therefore, the area of the semicircle is given by 1 over 2 pi r squared. Radius of this semicircle is 32. So we substitute in the values of 32. And subtract the area of the segment PSRQ that we have found in previous part, that is 7,153.68. Use your calculator to get the answer, that is 892.82 cm squared. Now we look for this shaded region. It's a sector, so we can use the sector formula to get the answer. From the question, you know that the radius of this sector is 24. And the length of arc ABC is equal to 37.36. However, the angle of this A and C is not given. Therefore, we rewrite this equation to 1 over 2r bracket r theta. R theta is equal to S, so this one can be replaced by S. We can substitute the radius is 24 and the S is 37.36 into the formula. Then get from your calculator. The answer is 448.32 cm squared. Therefore, the area of the shattered region is equal to the area of the shattered region PQRB plus the area of the sector NARB, that is 892.2 plus 448.32. We get the final, that is 1341.14 cm squared. Example 9. The diagram shows the cross-section of a log floating in water. The cross-section is a circle with center O of radius 90 cm. The chord AC is at water surface level and the highest point B is 18 cm above the water surface. Find A. The angle of AOC in radians. B. The cross-sectional area above the water surface. Now we solve for part A to find the angle of AOC. That is this angle. I enlarge this part for you to have a better look. I'll draw a straight line through AC, another straight line to BO, and notice that now I have formed two right angle triangles. From the questions we know that the radius of the circle is 90 and the height from the point B to the chord AC is 18. Therefore, the height from the chord AC to the center O here will be 90 subtract 18, that is 72. Now we can use the trigonometry function to find the theta. From the right angle triangle, we know that this 72 is the adjacent and this 90 is the hypotenuse. Therefore, we can use the cosine function to find the theta. Cos theta is equal to 72 over 90, that is 0.8. Theta is equal to shift cos 0.8, that is 0.6435 radian. The angle of AOC is equal to 2 times of the theta. Therefore, we need to multiply 2 with the 0.6435 and get my final answer, that is 1.287 radians. Part B is to find the cross-sectional area above the water surface. That is this part. Let me enlarge the diagram. From the diagram, we can see very clearly the cross-sectional area above the water surface is the area of the segment. We can use the formula of the area of a segment, 1 over 2r squared, bracket theta minus sine theta, to get the answer. Cross-sectional area above the water surface is equal to 1 over 2 multiplied with the radius, that is 90, and the theta 1.287 radian, and the sine theta. Again here, the sine theta must be in the units of degree. Therefore, we need to do the conversion first before we substitute in. 1.287 multiplied with 180 degree divided by pi, and we get the angle of 73.73 degree. Then use your calculator, get the answer 1324.35 cm squared. Let's look at the example 10. Diagram below shows two semicircles ARB and BQC, center at M and N respectively. The semicircle touches each other at point B. The straight line PQR is a common tangent to the semicircles at point Q and R. It's given that AB is equal to 10 cm, BC is equal to 6 cm, chord AR is 8 cm, and AP is a straight line. Find the angle of RNB in radian, that is this angle. From the questions we know that AB is 10 cm, means that the diameter of ARB is 10 cm, then its radius is equal to 5 cm, and MR is also equal to 5 cm. The angle of ARB is 90 degrees because the angle subtended by the diameter or semicircle is 90 degrees. Since the triangle of ARB is a right angle triangle, therefore we can use the Pythagoras theorem to solve for RB. That is square root of 10 squared minus x squared, and we get 6 cm for it. Now look at the triangle of RMB. We have 3 sides and 1 unknown angle. We can use what we have learned in solution of triangle, that is cosine rule. C squared is equal to A squared plus B squared minus 2AB cos theta. For triangle RMB, A is equal to 5, B is equal to 5, C is equal to 6. We have 6 squared is equal to 5 squared plus 5 squared minus 2 multiplied with 5 and cos theta. That is angle of RMB. Then do it carefully and you will get the answer. Angle of RMB is equal to 73.73 degrees. That is equal to 1.287 radian. From the questions, we know that BC equal to 6 cm. This is the diameter of the semicircle of BQC. That means that its radius is equal to 3. The perimeter of the shaded region is made up of 3 lines. That is the arc RB, the arc BQ, and the line RQ. Let's look for the arc of RB by using the formula R theta. We substitute R equal to 5 and the angle RMB, that is 1.287, into the formula, and we get the answer 6.435. Arc of BQ is equal to the radius, that is 3, multiplied with the angle here QNB. This angle is given by pi subtract 1.287. We get 5.565. Last, we find RQ. The length of RM is equal to 5. QN is equal to 3. Then I draw a straight line QS that is parallel to MN. Since the length of QN is 3, RN is 5, therefore the length of RS is equal to 5 subtract 3, that is 2. And the angle XRQ is equal to 90 degrees because the angle between the radius and the tangent RQP is always 90 degrees. The length of QS is equal to length of MN, that is 5 plus 3 is equal to 8. We have constructed the right angle triangle XRQ. Then we can use the Pythagoras theorem to solve for RQ. RQ is equal to square root of x squared minus 2 squared, that is square root of 60, and is equal to 7.746. Now we have all this information. We can calculate the perimeter of the shaded region, that is sum of 6.435 with 5.565 and 7.746, and the final answer is 19.746 cm squared. Part C. Let's find the area of the shaded region. The shaded region is equal to the area of the trapezium MNQR. Subtract the area of the sector RMB. Subtract the area of the sector QMB. Let us find the area of the trapezium first. Rn is given 5, Qn is given 3, and these two lines are parallel lines. The angle of RMN is 1.287 radian, and the angle for MRQ is 90 degrees. And the height of this trapezium is RQ, that is square root of 60, which we have found it from previous part B. Now we can use the formula of trapezium to find the area. That is 1/2 sum of the two parallel lines, that is 5 plus 3, multiplied with the height, that is square root of 60. Then we get 30.9839. Next, we find the area of the sector RMB by using the formula 1/2 r squared theta. For the sector RMB, the radius is 5, and the angle is 1.287 radian. We get the answer is 16.0875. Then we'll find the area of the sector QMB using the same formula 1/2 r squared theta. And the radius for this smaller sector is 3. And the angle here is equal to pi subtract 1.287, that is 1.855 radian. And we get the answer at 0.3475. The area of the shutter region is equal to 30.9839, subtract 16.0875, subtract 8.3475, and we get the final answer is 6.5489.
Let's try some questions for this topic by using the QR code or link shown on the screen. You can check your answer with your teachers.